Okay, you might want to listen to this first. Okay. Hey, number 32 and 33, talking about how to find the seventh term, how to find any particular term for that matter. One way to go about it is to kind of reference previous problems. So like if I reference number 31 and the work we did for 31, it might help with 32 and 33. So here's the work I had for 31. And if I'm looking at, say, let's say on this one I want to find the third term. Okay, the third term, 1, 2, 3, the third term has this C, has a C choose 2. Now I'm going to emphasize this number right here because that number and that number are the same. Okay, now I don't know if you can see that now because I highlighted it, but that's a 2 and that's a 2. Okay, and if we've kind of looked here, that number and that number are the same. Whoa. That number and that number are the same, so they're always the same. Right? So if I want to find the third term, 1, 2, 3, I'm at 5, choose 2. What if I wanted to find the fourth term? What would I be at in terms of my combination?
5, choose 3.
5, choose 3. How about the first term?
5, choose 0.
0. So how could you figure out what combination to use? Yeah.
You use like the power, so like use the power and then out of that choose and one less of what term it's telling you to find.
Good. So this number, you use this power, and if you're trying to find, say, the second term, you use the combination. That's one less than that. Okay. So let's say if I was, if I had a bigger polynomial, say like number, I guess this one was number 31. I don't know which one I was using there. Okay. I'm using number 31 and it has 8. If I wanted to find the sixth term, I would need to use the combination of 8 choose what? 5. Okay, 8 choose 5 because the sixth term, if I count over 1, 2, 3, 4, 5, 6, since we start at choose 0, it's always one less. And remember that this and this are always the same. Everyone with me on that? Okay, so really when you're going through the process of trying to find the seventh term here, well, we know that in this combination, we know we're at 11, choose something. Well, if I'm trying to find the seventh term, tell your neighbor what number you're choosing here.
6.
Good. You're choosing 6. Okay? Everyone with me on that? And then we have x to the some power, and we have 1 to some power. Now these two powers are always the same. Okay? Remember, these two powers are always one less than the term you are trying to find. Okay? One less than the term you're trying to find. So in this case, since we're trying to find the seventh, it would be 6. This one right here, this power, I'll let you guys write that down there. Our power for x and our power for y always have to add up to what? 11. So in this case, this one is 5. And it's 5 because these two things always add up to the degree. Okay, so we're saying it has to add up to 11. All right, now there's a formula that goes with this, and I had the formula on the answer page. Some of you may like the formula. Some of you may go, that just way confuses me. I don't even, I get it right now, so I don't even want to look at the formula, or I don't focus on it. But the formula, well, let's figure this one out first. Let's finish this problem, then figure out. What is 11 choose 6? Everyone do it on your calculator there.
462.
462. Okay. X to the fifth. Well, in our x position, we actually have just x. So that doesn't change. It's just x to the fifth. In the y position, do we have y? We have negative y. So we actually have negative y to the 6th. When you raise a negative to an even power, what happens?
It's positive.
It becomes positive. So this answer is actually 462 x to the 5th, y to the 6th. Now if that was an odd power, that would make that y negative, which would mean I'd have a negative that would pull all the way out to the front here. It would be negative 462 x to the 5th, y to the whatever odd power. But since it's even, it becomes positive. Any questions on that? Here's the formula. If you can think of it as if you can think of your term as your term of k plus 1. Okay, so actually I'll show you your work here. Okay, that's equal to c, or to nck, and x to the n minus k, and y to the k. That may be more confusing to you than the way we just discussed it. Yeah.
And that's the formula to find 32 and 33?
Yeah.
Like that. Okay.
Yeah, so when I say, when I'm saying k, you need to understand that k is always one less than the term we're trying to find. Okay? So this, if we think of k as one less than the term we're trying to find, that means we're doing 6 plus 1. That's 6. That has to be 11 minus 6, and that's 6. Okay? All right. I don't want to make it terribly confusing, but there's the formula in generic terms for you. Okay? I want everyone to try number 33 right now. So giving 33 a shot. I'll cover that part up. All right, let's see how we got it here. This one's a little more complex because the number gets quite big. All right, so if I'm taking a look at this, this would be, if I'm trying to find the 7th term, I'm at 16 choose 6, x to the 10th and y to the 6th. Okay, those two have to add up to 16. That's one less. All right. And then when I go to the x, that's my x position. So I have 16 choose 6 and 3x to the 10th. And this is my y position. So that's 2y to the 6th, which is actually 16 choose 6 times 3 to the 10th. Let's see that there. Let me move that up. Times 3 to the 10th times x to the 10th times 2 to the 6th times y to the 6th. So make sure you bring that into both parts. Okay, and then really I'm multiplying this by this by this. And then I'll have x to the 10th and y to the 6th on the end. When I do that, you get a big, long number, right?
3 billion about?
You have it on your calculator?
He does.
Scientific notation.
Okay, yeah. All right, so when you multiply those things together, you get that. Right there. Let's see. Make that a little brighter. Okay. 3.026332109 E10. That means scientific notation. Okay. That means the E means times 10 and then to the 10th power. All right. So what I'm going to do is I'm going to write down that 3.026332109 E10. Okay, there you go. So times 10 to the 10th. Now, when I have scientific notation, if you recall, really that just means you're multiplying by 10 times. And each time you multiply by 10, it moves your decimal one place. 3, 4, 5, 6, 7, 8, 9, and you got to put a 0 at the end, 10. So I actually have 3026332190 when I multiply it out. Comma, comma, comma. Okay, so we have 30,263,321,090 x to the 10th, y to the 6th. That is our solution.
That's pretty impressive.
It's pretty neato burrito, I agree. All right.
Do you need the extra 0 out there?
Yep, you got to have that place value. Otherwise, you only went 10 to the 9th.
Oh, yeah.
Yeah.
Got it right.
Nice.
It's pretty creepy.
Any questions? All right.
Things wrong.
You get those last two correct, number correct out of 10 with a percent. Turn it in. I'll get it back to you before you leave class.